If you've ever tried number theory before, you've probably seen a question like this. Let there be n cells in a jail, all locked. For each cell, when its control button is pressed, if the cell is locked, it becomes unlocked, and if it's unlocked, it becomes locked. So basically, pretend this is a switch. It'll just flip between being locked and unlocked. So that's how the control button works. There's a problem that causes the buttons for all the cells to be pressed. For cells to be pressed. First, all the cells are affected, then every second, then every third, until the nth cell is affected. So there are n cells. So it'll be basically 1, 2, 3, 4, 5, 6, 7, 8 until n. What are the least and greatest possible values of n so that exactly 79 cells end up unlocked? Okay, so let's think about how a cell would end up unlocked. It begins locked, right? Then it'll become unlocked, then it'll become locked, then it'll become unlocked, and so on. So it begins locked. So once the first button is pressed, it'll become unlocked. This will be the second, this will be the third button press. So we can see that for any odd number of presses, so if there's an odd number of presses to the button, it'll be unlocked, right? Odd number of presses. Now, when is it getting pressed? Well, think about it, right? All of them are going to get pressed on the first time. Then if you're a multiple of 2, you're going to get pressed like when n equals 2. When, sorry, not when n equals 2, when it's like this, all the, every 2 cells. Every 3 cells, all the multiples of 3. So basically for every number of which you're a divisor, you'll be pressed. And you need an odd number of these. So essentially you need an odd number of divisors, right? So if you have an odd number of divisors, what's the formula for divisors? Well, let's pretend our prime factorization for like our number x is a to the uh, b times c to the d times e to the f and so on. You probably remember this formula. It's b plus 1 times d plus 1 times f plus 1. Sorry, times f plus 1 and so on. Now we need this to be odd. So if it's odd, each of these has to be odd. The b plus 1, d plus 1, f plus 1. They all have to be odd. Because if they're even, what do you think is going to happen? There's going to be an even term, which means there's a factor of 2, which means the entire answer is going to have a factor of 2 and hence be even. So that means that each of these is odd. So if b plus 1 is odd, and the same applies for all the other ones, then b is even, right? So this is going to be an even power, this is going to be an even power, this is going to be an even power. So essentially x is going to end up being some perfect square. Okay, so this means that it's a perfect square. Now that's a pretty important breakthrough. And let's test this. Does this actually work? What if there's only one cell? Or let's say your cell number 1. You're going to one when all the cells are opened, when basically every first cell is opened, you're going to be open, and then that's it, you're done. What about if you're number 4? So at 1 you're going to be unlocked, at 2 you're going to be locked, and then at 4, which is your final divisor, you're going to be unlocked again. 9, same thing, it'll be 1, 3 and 9 this time. So this works out well. So now we've got perfect squares. That's our main concept here. What are the least and greatest possible values of n so that exactly 79 cells end up unlocked? So we want the 79th cell to get unlocked. So the least value will just be if the 79th cell is a final cell and that one gets unlocked. So it'll be 79 squared. 6241. That's a minimum value. Now the maximum value we'll have is, when could we get 80? It'll be one less than that. One less than the minimum value for 80 cells being unlocked. 80 cells means 80 squared, which is 6400. So just do that minus 1, which gives you 6399. So our minimum value is 6241 and our maximum value is 6399. So I hope you enjoyed this question. I hope you understood this main concept of understanding how you go around getting a cell to be unlocked at the end, and then using this prime factor trick, I guess, over here, and then just quickly doing the calculations. So this was a good question. Let me know if you enjoyed it. Let me know what other questions you have in the comments. Thanks for watching.